This time I'm gonna equip my cluster box with a series of Blinkenlights. You know, this array of fancy lamps old computers were typically equipped with. The other day I received a small package from Pimoroni in UK containing a series of Blinkenlights on a board named Blinkt! A Raspberry Pi Zero to drive them, and for setup and testing a small USB network adapter. First I'm gonna unpack my Raspberry Pi Zero. As you may know, the Zero is not equipped with a panel header, so you've gotta solder one, or you can get a so-called hammer header you can attach to the Pi without soldering. Just one short advice: you should buy one more hammer header than you need, because when you make a mistake and the header gets broken, then it's, well, broken. So it's always a good idea to buy one more. Pimoroni delivers the hammer header together with 2 fixing screws and a couple of plastic rails, so that you won't damage the header itself when hammering it to the Pi Zero. But always be very, very cautious when laying out the hammer header and these plastic rails, so that you really don't make a mistake here, because this can end up deadly. Attach the Pi Zero to the plastic plate and then lay the header on the holes of the Pi Zero. Don't forget about the 2 screws, which will hold the Pi in place when hammering. Then fix the rail above the header with the 2 screws, and then use a light hammer or something heavy and stable to hammer. Don't hammer too gently, as then the header will not be fixed to the Raspberry Pi. But also don't hammer too hard, because then you could damage both the header and the Pi. After that, check whether the header is attached firmly to the Pi and none of its contacts are bended or even broken. Nicht wirklich. Okay, der ist schon mal gescheitert. Finally, remove the screws and the plastic rail and plates. Now you can install the Blinkt, but first you should insert the micro SD card with the operating system image. Make sure that the Blinkt is orientated in the correct direction. Push the Blinkt firmly into the header until it sits snugly. Note that the Blinkt will not be directly attached to the Pi when installed in the cluster box, so we will need a flex cable with plugs to connect these two parts to each other. Once you are done with Blinkt itself, it's time to attach a power supply and the network hub to the Pi. The left USB-C jack is for peripherals like the network unit, whereas the right one is for power delivery. Use an off-the-shelf USB-C power supply. First connect the network hub to the left USB-C jack, then attach a Cat5 or Cat6 networking cable to the RJ45 jack on the backside of the network hub. After that, connect the power supply, which will make the Pi boot up immediately. You should see the power LED of the Pi starting blinking. And after some 15 seconds, the Pi should be ready to use. A short note on the pinout of the Blinkt. The Blinkt only uses 4 pins, one for power supply, one for ground, one for data, and one for the clock signal. So you can use the other GPIO pins on the Pi for other projects just as you wish. This will allow us to gather external data to steer the LEDs on the Blinkt with. As always, it's a good idea to perform an operating system update on the Pi beforehand. So first, let's log into our router to find out which IP address our Pi received, and then use SSH to log into the Pi. Then issue the well-known sudo apt-get update and upgrade commands to get a fresh list of updates and then to install these updates. These may take several minutes as the Pi Zero is a fairly slow device. Now it's time to install the driver for the Blinkt. Unfortunately, the standard driver supplied by Pimoroni did not work on my Pi Zero because of the Python environment, which is externally managed on Raspberry Pi OS, so that you can't add any external libraries. So you have to clone the latest version of the driver from GitHub, copy it to the Pi, and then start the installation process. This will create a new virtual environment on your Pi. You can also install the full Blinkt driver documentation if you wish. Don't forget to install example scripts, as we will need them. Once the installation process is done, Let's dive into the examples directory to pick one of the example scripts to test our Blinkt. I picked the Larsen Hue script, which is quite a good example for all those of you who love the Knight Rider series, as it will bring the famous red scanner light on the front of Kit to your Blinkt. Before that, however, we have to change into the newly created virtual Python environment by using the activate command. After that, we can start the script. And yes, the LEDs on the Blinkt are blinking in a very colorful manner. Use Ctrl+C to stop the show. Of course, we'd like to get the show started automatically once the Pi boots up. This, unfortunately, requires us to add a bunch of code into the Python script in question, as the script must be aware of Unix signals like int or term being issued so that it can stop in an orderly manner. If we don't do this, the LEDs will remain switched on after system shutdown. Just open the script with some text editor and paste the necessary code into the beginning of the script, as shown here. So we will have to write a shell script which combines the activation of the virtual environment with a call to the Python script, which then operates the LEDs. Once you've saved the shell script, you must dive into the systemd directory of the Pi to create a service file so that the Pi will start the script when booting. Use the shell script as exec start and add 2 lines which make the startup script aware to seek int and seek term signals so that the script will be closed in an orderly manner when the Pi is being shut down. Once you've saved the service file, issue a system control enable, and after that a system control start with respect to the service file you created, and then the Blinkt LED show will start upon boot.